Alrighty, so let's go ahead and get started with our unit on chemistry. Now, of course, when we start chemistry, we have to understand what matter is because chemistry is just the study of matter. And so let's talk about matter. Matter is anything that has mass and takes up space. So essentially everything around you. Please keep in mind it's the things that you can see and also the things that you can't see. Matter has a lot of properties that can be used to identify and classify it, whether something is hard or soft, hot, cold, whether it is flammable or not flammable, combustible, not combustible, what phase of matter it's in, whether it's a solid, a liquid, gas, or plasma. And again, chemistry is just the study of matter and how it changes. Now, some types of matter are considered substances and some are not. So what exactly is a substance? It is a single type of matter. It is pure or it can have a specific composition. So what I mean by that, pure types of matter would be something like an element, the atoms of an element, or a single type of matter, something with a specific composition would be something like salt. Table salt, sodium chloride. It doesn't matter whether it comes from seawater or from a salt mine. It has that same composition. So why is one type of matter different from another? Well, Empedocles proposed that matter was made of 4 elements: air, earth, fire, and water. And people believed this for over 2,000 years. So, again, this ties in those theories that we've been talking about recently. They will be believed until someone comes along and disproves them. And it wasn't until the late 1600s that scientists learned that matter was made up of more than just 4 elements. And those elements were not air, earth, fire, and water. Scientists know that matter is made up of more than 100 different substances, and those substances are called elements. Elements cannot be broken down into anything simpler by chemical or physical means. Elements are the simplest substance. And of course, those elements are made up of atoms. The atom has a positively charged center surrounded by a negatively charged cloud. Elements have different properties because their atoms are different. And we're going to talk very carefully about atoms, their structures, and how they are different. Now, atoms of most elements are able to bond with other atoms. And when they bond, they form these chemical bonds, which create these larger particles called molecules. So if we take a look at our water molecule, we can see there is 1 oxygen and there are 2 hydrogens. They are chemically bonded together. When those elements combine, the compounds that they form have different properties than original elements. So hydrogen and oxygen are both have specific properties, but when they bond together now, those properties change. And now water has specific properties, different from the hydrogen and the oxygen. We can represent the compound by what is called a chemical formula. All that formula does is show us the ratio of the elements that are in the compound. So here's another example: carbon dioxide, CO2, 1 carbon atom, 2 oxygen atoms. And we can see that in the formula as it's written. Now, elements and compounds we know are substances, but most materials that we come across are mixtures. And a mixture is just when 2 or more substances have sort of been mixed together, but they are not chemically combined, and so their properties do not change. 2 types of mixtures: heterogeneous, where you can see the different parts, and you can see this fruit salad here. We've got kiwi, strawberry, banana, pineapple. All of those different substances are just mixed together. They're also homogeneous, and that means the substances are evenly distributed and you cannot see the different parts. So something like apple juice. It appears to be the same throughout. Okay, states of matter, simple, you've done this before. Solids have definite shape and definite volume. Liquids, definite volume, but no definite shape, takes the shape of the container that it's in. And gases, no definite shape or volume. They will expand to fit the container, um, whether it's a liter or 10 liters. Couple different types of solids. There are crystalline solids, and those are solids that are made up of crystals. And then there are amorphous solids, and that's when the particles aren't really arranged in a regular pattern. Liquids. Some properties of liquids. They have surface tension, which is this inward force that brings the molecules on the surface close together. And so that's why water sort of bubbles up. It's got that surface tension. Liquids also have something called viscosity, and that is the resistance to flowing. Liquids with a high viscosity, something like maple syrup or oil, will flow very quickly. Where things with a low viscosity, or excuse me, things with a high viscosity, I apologize, things like maple syrup, and motor oil will flow very slowly, while things with a low viscosity, something like water, flows very quickly. And gases. Now, gas particles, like we just talked about, will move and spread apart and fill up all the space that they have available. Those gas particles, because they are moving, will constantly be colliding with each other and, of course, the container that they're in. And this creates this outward force or this pressure. Now, if we increase the temperature of the gas, those particles will move more quickly, bump into each other more often, bump into the container more often, and will increase the pressure because, again, we're giving that gas more kinetic energy and causing them to move faster. Okay, that is a quick little introduction into matter. See you next time.